Supposed to be left with millions.
All right. Relax. Okay, so this problem set is all about systems of equations and inequalities. So a system is just when you can have a system of 100 equations. That's what actually happens in statistics a lot, is you have all this data, and so you effectively have hundreds of equations, and you have to kind of resolve them and say, how can we have a model that kind of makes all these equations sort of agree with each other in a fuzzy way? That's, we talk about like regression models.
I'm getting a phone call.
I mean, I don't know what to tell you. It's like the basis of like a large amount of technology and stuff nowadays. So it's yeah, I don't know. I think statistics are very interesting, but okay. So anyway, so this is simple. This is gonna be very, very like two equations. There's gonna be one answer to the system, or it could be no solution, I guess. Or
Are there any no solutions on here?
I can't remember.
That's gonna complicate.
I'm gonna give you a quick little review. This is actually the first page is from Algebra 1. So it's been a few years for you. I'll kind of jog your memory here. Here's one. What are those? Well, it's a brand new meme. It just came out yesterday. X plus y equals 4, and 2x plus 3y equals 7.
Those are just lines.
Exactly, yes, very good. That's a line. And this is a line that I think is a little bit less steep, but something like that. The idea, though, is that those guys are going to cross somewhere, right? And they're going to cross at an xy coordinate pair, right? Well, that x and that y are the two solutions to the system, right? So you can phrase these questions in a lot of different ways. Like this one, the simplest way you can phrase it is, are there two numbers out there? Do two numbers exist that if you add them, you get 4? But if you double the first one and triple the second one and add them, you get 7. Is that possible? And in this case, we're going to say yes, there's a pair of numbers. So just looking ahead, though, so as an answer your question, how could two lines have no solution?
They're parallel.
If they never cross. So if they're parallel, it is possible. I'll give you a really simple example. X plus y equals 1, and x plus y equals 2.
Okay.
If this were a system, it may or may not be obvious that, no, you can't come up with two numbers that add up to make 1 and also add up to make 2. It doesn't really make sense, right? So let's deal with it. So does anyone remember a technique for solving this? There's a few.
Don't you solve for like
y
x or y and then you plug it into the next equation?
Or you like
That's
get
what
them
one-
to be a like term.
That's called substitution. Let's do it that way. Substitution. So what that is like exactly what you just said. You solve one of them. So you go, okay, let's like solve this guy, for example. And it's up to you. Which one do you want to solve for? You want to solve for x, or you want to solve for y?
Let's solve for x.
Solve for x, sure.
Okay.
It's total. I'm not going to sit here and show you every permutation of how to solve this, okay? I'll run you through an elimination on B, but it'll be, anyway. X is 4 minus y, right? Everyone's okay with that?
Yep.
That makes sense?
Yeah.
And now, that's a true fact, right? So anytime I see an x,
You plug that in.
I can replace, any x I see, I can replace with a 4 minus y. So now this bottom equation reads, by the way, some people, can you imagine the mistake someone might make if they plug this back into the thing they got it from? That's called it's circular, That's like saying, oh, Tom Brady is the best quarterback because he's better than all the other quarterbacks. I'm like, bro, you went in a circle. Tautology. Okay, so you get 2 times 4 minus y plus 3y. Don't forget the parentheses, right? Now solve. Distribute.
8 minus 2.
Minus 2y. 7.
And then can you just do 8 plus y? No.
Well, you have negative 2, you gotta combine like terms, right? You have
So
negative
you get
2y
y.
plus 3y makes a single y. And then subtract 8 from both sides, you get -1.
You're not done.
We're not done yet.
Now you plug it into
Whatever one.
whatever
Doesn't
one you
matter.
want.
Yeah, whichever one you want. So this one looks pretty good. This one seems pretty simple. So x is equal to 4 minus y. So that means that x is what? 5.
So then do you write it as can you write it as like a coordinate?
You could. Which means my drawing wasn't very good. The intersection is actually like somewhere over here, but you know, close enough for government work, as Michael J. Knudsen would say.
When you're doing the
Good.
that's where you find the
You guys feel okay about that? Any questions?
Yeah.
This is if you only were to learn one method, it's probably substitution because you can apply substitution to a nonlinear system. Okay, this is a linear system. Linear meaning line. This is linear because both of these describe lines. But if you look forward in your problem set a little bit, you'll see we pretty quickly get into some systems where it's not 2 lines; it's 2 curves or something. So, all right, let's do an elimination. We'll do it on B. And B is very nice one for an elimination. Do any of you guys see why
because you can subtract 2x from 5x. Isn't that what you do?
you're close?
Or you can add y or
Let me-
subtract y.
Let me set this up real quick, just with a general principle. The general principle is this. This is like those, I know people don't use Facebook anymore, but it'll be like,
I use
it would be like, for genius only, Apple emoji equals 2.
These are on Instagram.
Grape emoji
That's a raspberry.
equals 3. What is Apple emoji plus grape emoji?
For genius
9.
only.
And it has that one emoji where the guy is like has like a monocle. And has his hand like anyway. Is it a monocle?
I think so.
Yeah.
He's like anyway. What's the answer to this?
5.
5. That's what elimination is gonna utilize. So it's a simplified version, of course. But. Okay, so what am I talking about? You have 5x minus y equals 13. And you've got 2x plus 2y equals -2. So here's the trick. You say, aren't I allowed to multiply both sides of an equation by any number I want?
Yeah.
So I'm going to multiply both sides of this equation, top
By
one, by
2.
2. So why would I do that? I'm going to
So
put.
the y's are the same?
I'm going to get the y's to line up. So maybe it's a little confusing for now. Let's just keep watching here. You'll see the trick. So 2 times 5x makes 10x. 2 times -y makes -2y. 13 times 2 is 26. Okay? Do you see how we're going to use this idea to make our life easier
Yeah.
with this pair? Because this is like the apple, and this is the grape.
Right.
Right? So we're going to say, now that we've modified this equation, I can say this plus this equals this plus this.
Right.
You can see why it's called elimination, because that actually eliminates the y's from the equation.
So you're adding them?
I'm going to add, so people will often say, I'm going to add the equations, which is an acceptable, like, it's not exactly precise, but we know what you mean if you say, I'm going to add those equations.
They're combining them.
Yeah, well, I'm going the left side plus the left side must be the same as the right side plus the right side, right?
Right.
So this plus this would make what? If I add up,
12x.
I'm gonna have 12x, right? Did everyone understand how I'm getting 12x there?
Mhm.
Okay. And the right side's gonna be 24, which means x is 2.
Then you go back.
And then you go back, you say, well,
Bring him to the second.
okay, so the second one says 2 times x plus 2 times y has to make -2. So that's a 4. Subtract 4 from both sides, and then divide both sides by 2. So it turns out my answer to this question is 2.
Easy.
And can we check our answer? do it mentally. Yeah, you don't have to show you're checking your answer in every question. Just is 5 times 2 minus -3 equal to 13? Yes. Is 2 times 2 plus 2 times -3 equal to -2? Yes, it is. Yay! How do we feel?
Feelings.
Stretching.
All right, I want to have some work time tomorrow, so let me just jump ahead and do a nonlinear one. Let's do 2 nonlinears.
Do like 1 for 2 and 1 for 2.
We'll keep it.
Just kidding, I don't really care.
What?
It's up to you.
It's up to me.
Yeah.
Like if you cry every time. Let's pick a good one here.
Yeah.
I'm thinking maybe 2B.
Okay.
2B will be fun.
Okay. To be or to not. To be or.
Well, so tomorrow when we have some work time in class, you can, knock out C, D, E, and F. I would generally recommend, do maybe 1 or 2 problems outside of class every day. It'll really help your understanding. It'll help you retain the information. But
Retain information.
what?
Said retain information.
Yeah, being able to retain information is a good skill to have. Okay, so I want to look at 2B with you guys. 2B. So this one says, is there a pair of numbers where x minus y makes 4, but x times y makes 2? Does there exist a pair of numbers?
No.
That doesn't. You don't think so? There's actually 2 pairs of numbers that would work for this one.
Really?
So is it like a positive pair and a negative pair?
I'm not sure, but that's a good question. How do you think I'm going to start the problem? I'm not going to do any algebra yet. I just want to know, is there a solution to this?
You can
And
graph
if there is, how many are there? You can graph it. So,
But how would that even look?
well, let's see.
It's just
This, maybe rearrange them to graph them, because this I can rearrange
x
as.
equals or y.
Y equals 4x. Or y equals negative 4x. Y equals something.
Add the y over, subtract the 4, y equals x minus 4. You okay with that?
Okay, that's what I got in my.
So, are we all okay with that? And then this guy, I can rearrange as y equals
2 over x.
2 divided by x. What does that look like?
Isn't it like this kind?
So maybe 2.
So, the answer to this question is not easy. This is definitely not an easy question. But now it's significantly less challenging because we know that there's a pair of positive numbers that works. Is everyone okay with how I know why I'm saying that's a pair of positive numbers?
Yeah, she's
Yeah.
x and y.
X and Y are both positive in that quadrant. And then down here, it's a pair of negative numbers. And also, if you kind of tilt your head, you can see that there's symmetry here.
You tilt your head a little bit, squint. It's like,
Yeah, there's a symmetry. No, did you see it?
I do,
The mirror is right here.
diagonal.
It's a symmetry over the line y equals negative x. Okay, algebra time.
Algebra time.
All right.
So you
Substitution is the spoiler alert. We're going to use substitution for pretty much any nonlinear system. Well, let me just say most of the time. If it's nonlinear, you're going to want to use substitution.
You can solve this for something.
Yeah, that works. So solve this for x. We get x equals y plus 4. We're all okay with that, right?
Yep.
Now I can replace this x. Okay, you get this page. Don't want you to miss it. Life-changing info. Okay, so this x is y plus 4 times y equals 2.
y squared plus 4y.
y squared plus 4y. This is gonna upset you guys, but
Because we have to factor.
Do we have to
Let's-
factor? it
Oh,
or
oh, you're
complete
doing
the
completing
square?
this.
well, consider this.
I actually like completing.
If this were factorable, you'd end up with two integers, right?
Yeah.
But it's pretty clear from this, right? The only pair of integers that could possibly work for this would be like a 2 and a 1, but 2 and a 1 doesn't work out. So sadly, we know it's not going to be factorable.
So add
Oh.
Is
I'm
that
gonna complete
good?
the square. Thanks, Maddie. You're the best. See what I did there? Maybe?
Yep.
So what have I done? I've made this side a perfect square.
Y
It's
plus 2.
y plus 2 squared. By the way, how do we know to put a 4 there? Well, half of 4 is 2, and 2 squared is 4.
Easy.
So that's the algorithm for completing the square too. Half of this linear coefficient is squared. And then half that number is what goes in here. Okay, so it equals 6. So y is equal to -2 plus or minus root 6. Is that okay?
Yeah.
We're sure there's no questions in the last step?
I just don't want to plug that in. But it's cool.
Well, you know what we're going to do is just say, we're pretty confident that, since I know there's two answers, well, there you go, there's two different y values. So -2 plus root 6 is this guy's y value, and -2 minus root 6 is this guy's y value. Does that make sense?
Yeah.
So now here's the trick. Is getting the x values going to be challenging?
Yeah.
Nope.
Oh, because all you do is add 4.
Yeah. I mean, it's challenging if you don't know what to do, if you're kind of like, oh, there's a lot of symbols up there, or, kind of lost. But once you know what to do, you go, well, my x value is just going to be adding 4. I just add 4 onto my y value and I'm good. So how do I know that? So every equation that's up here is a true statement about the pair of numbers, right? So this statement right here, right, that has to be true. Otherwise, we're getting into some crazy realm of, doing. That make sense?
Yeah.
You could certainly find your x value by going 2 divided by your y value, 2 divided by y. But since given the way the number is written, it's going to be much easier to just add 4 to it. So this last step might confuse you. So be ready. I'm going to write the two numbers. Are we ready? The first one, I'm going to say one of my y values is -2 plus root 6, right? How do I get the x value?
Add 4.
I got to add 4 to it. What happens if you add 4 to this?
It just becomes 2 plus root 6.
Okay. Are we okay with that one?
Yeah.
So next, my other y value is -2 minus root 6.
So that's just 2 minuses.
There's our answers.
That's cool.
Here's the maybe a slightly tricky thing. How many solutions were there to our system?
4? Or was it 2?
A little confusing, right? It involves 4 different numbers, right? Although some people might say, aren't there 8 numbers in there? No. It's debatable. That's a number, but that pair of numbers is a solution to the system, right? Coolio, yeah. Let's we only got 4 minutes left to do it.
Where are you going?